In this particular question, we'll be looking at the properties that make a molecule either an aromatic compound or an anti-aromatic compound. So let's pick the question. Anti-aromatic compounds satisfy the following criteria, except that they are A. Planar, B. Cyclic, C. Have 4n pi electrons, or obey Huckel's rule of 4n plus 2 pi electrons. Which of these options do you think is the odd one out? Well, before we get to picking the correct answer, we have to know that we can actually categorize molecules into 3 types based on their electronic properties. And when we say electronic properties, we are referring to the characteristics of a molecule that arise from the behavior and arrangement of its electrons. And these electronic properties include electron delocalization, electron density, energy levels, and electron configuration. So the categories under which these molecules can be put are either being aromatic, anti-aromatic, or non-aromatic molecules. But with respect to this particular question, we'll only be paying attention to the first two, aromatic molecules and anti-aromatic molecules. Aromaticity is basically a state of molecular stability that arises from the delocalization of electrons in a planar ring-shaped molecule. And for a molecule to be considered aromatic or anti-aromatic, there are some rules that the molecule has to follow, or there are some specific properties that we look out for in that molecule before we qualify the molecule to either be an aromatic compound or an anti-aromatic compound. So we'll be looking at the rules using specific examples under each of the categories. So the examples we're using will be benzene and cyclobutadiene. So the cyclobutadiene is basically an alkene with 2 double bonds. So it's a cyclic alkene with 2 double bonds. So let me draw out the structure of each of them and see. So these are their structures, and take note that each point over here means there is carbon here. So there is a carbon here, another carbon here, carbon here. The same thing applies to this. So this is the structure of cyclobutadiene. Now, benzene is actually an aromatic compound and cyclobutadiene is an anti-aromatic compound. So I'll be using these 2 examples to help us answer our question. So these are the rules required for a compound to be considered either an aromatic or an anti-aromatic compound. And the first rule is that the compound has to be cyclic. And the same thing applies to anti-aromatic compounds. They also are cyclic. And this is obvious from the structure of benzene that we have. So you realize that the structure of benzene is a closed ring structure. And the same thing applies to the cyclobutadiene. So that is what you mean by the molecule being cyclic. It should be a closed ring structure. That will make it fit the rule for being either aromatic or anti-aromatic. The next property that we look out for in aromatic compound is that the molecule should be conjugated. And the same thing applies to anti-aromatic compounds. Anti-aromatic compounds are also expected to be conjugated. Now, what we mean by the molecule being conjugated is that there should be alternating single and double bonds present in the molecule. Alternating single and double bond. So if you look at the benzene molecule, we have a single bond here and then a double bond. Single, double, single, double. in that order. So alternating double and single bond means that the molecule is actually conjugated. And the same thing applies to the cyclobutadiene. There's a single bond here, then we move on to a double bond, single bond, double bond. What is the next property of the molecule? The molecule should actually be planar. The same rule applies for the anti-aromatic compound. Now, what do we mean when we say the molecule is planar? What it basically means is that the molecule should be flat. We don't want any 3D shape. And then that means that if the molecule is planar or flat, that means the atoms, the carbon atoms that make up the benzene molecule or the cyclobutadiene molecule should have only sp2 hybridization. We don't want any sp3 hybridization. So no sp3. Let's check that out and see if the carbon atoms here are all sp2 hybridized. Actually, for this benzene molecule, all the carbons here have only sp2 hybridization. The same thing applies to this molecule. All the carbons here have sp2 hybridization, no sp3 present. The reason being that immediately we have an sp3 hybridized atom or carbon here, then the molecule will no more be planar. It will not be flat. It will have 3 dimensions. So that's why this rule is so important. Now the last rule we have to check has to do with the Huckel's rule. And what the Huckel's rule for the aromatic compound is that there are 4n plus 2 pi electrons. Now what this rule is trying to say is that for every aromatic compound, the number of pi electrons present should have this formula 4n plus 2. It should comply with this 4n plus 2. And this n here can be any number starting from 0, 0, 1, 2, 3 and above. It shouldn't be negative. So if n is 0, that means 4 times 0 is 0 plus 2. So that means if a compound that follows all these 4 rules we've mentioned here and has 2 pi electrons, then it's an aromatic compound. What about if n is 1? If n is 1, 4 times 1 is 4 plus 2. That gives us 6. If n is 2, 4 times 2 is 8 plus 2. That gives us 10. If n is 3, 4 times 3, 12. 12 plus 2, 14. If n is 4 times 4, 16. Plus 2, 18. So if the molecule has either 2 pi electrons, 6, 10, 14 or 18 pi electrons, that means it follows this rule and that makes it an aromatic hydrocarbon. But one interesting thing for anti-aromatic hydrocarbon is that it doesn't follow this rule of 4n plus 2, but follows a different type, which is 4n pi electrons. So for these particular molecules, anti-aromatic molecules, their pi electrons are in multiples of 4. So n here is any integer starting from 0, but specifically for the anti-aromatic compounds, n shouldn't be 0, because if n is 0, that means the pi electrons are 0. But we don't want it that way, so we start from 1. So if n is 1, that means 4 electrons. N is 2, 8. Then move to how many? 12. Move to 16. Move to 20. In that order. Good. It continues. So if the number of pi electrons are 4, 8, 12, 16, 20, then that means the molecule in question is what? Anti-aromatic. As long as it is cyclic and conjugated and planar and follows this rule, meaning it is anti-aromatic. So let's look at our benzene structure again. So now let's count the number of pi electrons present in this benzene molecule to see if it follows the Huckel's rule. Now take note of this. For us to have a pi electron, that means the molecule should have either a double or triple bond present. And for double bonds under hybridization, we must have known that if a molecule has double bond, one of the double bonds is actually a pi bond. So for this double bond here, that means one of them is a pi bond, and each bond has 2 electrons. So if this is a pi bond, that means we have 2 pi electrons here. We have 1 over here, so 1 pi bond here, another pi bond, another pi. So we have 3 pi bonds, and each of them has 2 electrons. So 2 times 3, that gives us 6. So that means benzene has 6 pi electrons. Now let's check the numbers. We have 6 over here. So since the number of pi electrons are 6, and benzene carbon atoms have sp2 hybrid orbitals and is planar and conjugated and cyclic, that means benzene is actually aromatic. Now let's look at the cyclobutadiene. There's a double bond here, there's another double bond here. One of them is actually a pi bond. So we have 1 pi bond, another pi bond. So we have 2 pi bonds, and each of the bonds has 2 pi electrons. So how many electrons we have? We have 4. If you pick the 4 and check it against the number of pi electrons needed in aromatic compounds, realize that 4 is not. You have 2, 6, 10. There is no 4 here. But for the anti-aromatic, we have 4 here. That means cyclobutadiene is actually an anti-aromatic compound. So now what can we say after understanding all the rules involving aromatic and anti-aromatic compounds? Let's come back to our question. So let's check. Anti-aromatic compounds satisfy the following criteria, except that they are now planar. We have it here, we've checked it. Cyclic, it follows it. Have 4n pi electrons, 4n pi electrons, it follows it. The only odd one is it obeys the Huckel's rule of 4n plus 2 pi electrons, and meaning this is our correct answer. So this is the odd one out, because this 4n plus 2 pi electrons is actually the rule or the property needed in aromatic compounds. So that means this is our correct answer. If at this point you've not subscribed to our channel yet, then do also subscribe to our channel so that you will not miss our future videos. And like our videos and share with your friends and colleagues. See you in our next organic chemistry quiz question.